Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on the standard normal table. At Walter State, we are using a standard z-table that gives us the area to the left. If you are using a different type of table, this video will not help you. So before beginning this video, be sure that you have access to a standard normal table that gives you the area to the left. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this multiple part video series for students. We are ready for topic 2, which is given a z-value, find the requested probabilities. In this case, we are ready for example 3. Find the probability that z is less than 1.02. Notice the difference in notation. We are now using an inequality sign and a P for probability. It's just a different type of notation. It's actually asking the same thing that we did in topic 1. We still want the area to the left since less than shades to the left on a number line, and area and probability are the same thing when dealing with a standard normal table. We need to find the probability that the z-value is less than 1.02. In this case, let's draw the picture or the curve first. Draw your standard normal curve with 0 in the center. Mark off 1.02, and since it's less than, we will shade to the left, and that will be important as a shortcut to help us remember less than left, both with L's. Then, since we're shading to the left, let's look up in our table 1.02. To do so, we want the edge to be 1.0 and the top to be the 2, so that'll be 0.02. That gives us an area or a probability of 0.8461. That is the area to the left, which is what we're looking for, what we consider our answer. So the area to the left, the answer is 0.8461. We are ready for another example. Let's find the probability that z is less than negative 0.72. Do you think that the negative will make a difference? Well, it makes a difference in the size of our answer, but it won't make a difference in the process. We need to find the probability that the z-value is less than negative 0.72. Again, let's start with a picture. Draw your curve, your center mark of 0, and label negative 0.72 in an appropriate place on the number line, in this case to the left of 0, because your negatives are to the left of 0. Again, it doesn't need to be to scale. Since we're shading less than shades to the left, less left. And we will look up in the table negative 0.7 and the 0.02, where the row and column intersects, gives us 0.2358, and that is the area to the left. Since we're looking for the area to the left, that gives us 0.2358. Notice in the last two examples that we had less than, we shaded to the left, and we left our table answers as our final answers. So we'll leave the table alone. less, left, leave. Notice the 3 L's. It only works for this one type of example, but when we're dealing with inequalities, there are 3 types of inequalities, and it will help to have at least one alliteration to help us to remember what this one is. Less, left, leave. Here is a student activity for you to try for your less than probabilities. And we're ready to move on to another example. Not all of our problems can be less thans or finding probabilities in areas to the left. There are other situations that are presented to us, and our next one has an answer that is the area to the right. However, the table only gives us area to the left. We will not have a table for every type of situation, so we have to figure out how to use the area to the left to find the area to the right. So we will be looking, given a z value, for the area to the right, and our table value will give us the area to the left. Remember that the total area is equal to 1. So the answer plus the table value will give us a total area of 1. So our answer can be found by taking 1 minus the table value. In other words, we're using the complement. So our answer again will be 1 minus the table value. So when we're looking for the area to the right, or greater than will be to the right and 1 minus the table value. No great alliteration like we had before, but they 3 things go together. Greater than, shades to the right, and our answer will be 1 minus the table value. Let's do an example. Find the probability that z is greater than 1.37. We need to find the probability that the z value is greater than 1.37. Take your graph, mark your 0, mark your 1.37. Because it's greater than, we shade to the right. That will be our answer. Then go to your table, look up 1.3, then the 0.07. That gives us 0.9147. Notice that what we shaded was a very small area, and 0.9147 is a very large decimal, very close to 1. So it doesn't make sense that that would be the answer. But it's not. It's the area to the left. Notice that Miss Borlaug is going to draw an arrow to the left-hand side, but our answer is on the right-hand side, so that will help us to remember to subtract 1 minus 0.9147 to get our answer, the area to the right, as 0.0853. We have time for another example. Find the probability that z is greater than negative 0.68. We need to find the probability that the z value is greater than negative 0.68. Draw your number line. Mark the 0.68, negative 0.68. And shade to the right. Greater than shades to the right. That will be our answer. When looking up 0.6 negative, it will be on the boy, did I just say that wrong. It will be negative 0.6 along the column, 0.08 along the top, so the row and the column intersect at 0.2483. That is the area to the left. That is the tail to the left. We will need to subtract that from 1 to get our answer that's to the right. 1 minus 0.2483. Sorry about that. I had to pause and answer the phone, and we were talking about subtracting our area that we found in the table of 0.2483. So we get 1 minus 0.2483 for an answer of 0.7517. And so that is the area to the right. And here are 2 problems for you to try. And we will not do another example. We will pause and end the video here. Thank you for watching.